I was an undergraduate at Hampshire College in Western Mass. This would have been 76, and I was doing a senior thesis or senior project on mapping and computer mapping. And I was kind of trying to dig out the literature on the topic. There wasn't a whole lot. There were a few ACM articles, a few special publications of the American Geographical Society, I think it might be. And I came across the Harvard lab log, one of the early lab logs talking about SimMap and SimView, and looked really interesting. And saw that it was in Cambridge, not too far, and got into town. I forget how, hitchhiked probably, to the lab and walked up and was kind of nervous. Looked through the door, saw some people hanging around a Tektronix terminal. It looked pretty interesting, and went in and introduced myself and met Alan. I think I might have met you, Nick, and Jeff Dutton at that time. So my connection was really through the lab log and finding out about the lab through the kind of software outreach stuff. It's funny, I got into that senior thesis project. It was originally going to be a landscape simulation model of agricultural land use change through time in western Massachusetts, looking at trying to do a simulation model with the effect of the transportation network and the opening of the West and all these things on the agriculture of western Massachusetts. And I thought, well, to run simulations, you need to have some sort of data. So at the very beginning, you need to actually have a data structure, a database to hold the geographic data. So as a prerequisite to doing the real thing I was interested, I got into this computer data modeling stuff, and I've sort of been stuck there ever since with how to represent points, lines, polygons. It's interesting, the field, a lot of the things that people talked about conceptually and said, it's no big deal, we can do these simulation models or whatever. It's turned out to be a lot harder to get the nuts and bolts working. But things are actually starting to happen that, people thought were just, a day or two, a year or two away, in the 60s and 70s, with, applying computers to stuff like that. But it was actually pretty good-natured how a lot of standing around at a whiteboard or a blackboard, together, kind of going through things. We did a lot of walking through of algorithms. I think on the philosophical issues like how much to put in the globals file, it was more of a, people took positions and argue and agree to disagree. But when you're actually going through algorithms like how to do how to deal with fuzzy creep and point in line intersection, we spent a lot of time just walking through, watching each other do through scenarios on the blackboard. I'd ended up becoming the lead of the Odyssey product, if you will. I think you, Nick, you'd gone off to get your PhD in England, so I was sort of given the job of, okay, let's bring this Odyssey thing to a head and let's ship it. We looked at licensing it to a number of places. ISCO, which was a computer graphics company in San Diego, was one that was looked at. Creating a Harvard lab spin-off company was one that was looked at. But this was all happening with all these politics at a higher level that I was mercifully protected from by Alan Schmidt. But there had been a change of management or leadership at the Graduate School of Design. There'd been, financial pressures on the lab to how do you keep, paying for these this research, these research associates, it was all, it was all kind of going on at the same time. In the end, it really turned out that Harvard really didn't know how to deal with software technology, how to commercialize it, and they just kind of said, "Oh, we'll just stop doing that," and walk away. And that was about when I left the lab. I'd been there 4 years. We were, getting tired of kind of living in the urban, living in Somerville, taking the subway or riding the bike to work kind of thing, and it was the right time for me to kind of move on. But it's too bad that the lab never really figured out what to do with Odyssey. On the other hand, it was a very difficult challenge. I couldn't imagine, could anybody have figured out how to take some sort of commercial software technology from a university setting into a commercial setting in 1979, 1980? I don't think anybody, it's a very difficult thing to do. I was looking for, what to do next. I went to a conference at University of Maine. It was on in-place resource inventories, forest inventory primarily, and there was a bunch of GIS kind of topics there, and that's actually where I met Jack Dangerman for the first time. Although he'd been involved in the lab and was kind of a name that you heard about in sort of vague ways, that was the first time I think I'd really met him. He might have been at some of the conferences earlier. I met Jack. We hit it off. He had very similar values that I did as far as building quality software tools for people and doing advanced kind of engineering work with computer graphics and GIS, and seemed like a good fit at a human level. And came out to interview in September. It was over 100 degrees for 4 days while I was here, and I ended up making the move. I figured I'd do it for 4 years, and I've been relisting ever since. The stuff that I got from Odyssey for early ARC that was really valuable to me were really some design principles, and I think the biggest one there was modular programming. The idea of decomposing a software system into a set of software modules which had well-defined external interfaces and had private implementation within them. And I think in Odyssey we had different types of modules. We had data structure modules, which hit a data structure like a heap. We had interface modules, which hit a interface to the disk drive or to the digitizing tablet. We had user interface modules, which managed the command line. We had graphics libraries or graphics display module. And then we had processing modules, which actually ran algorithms through things. So everything is broken into modules. Every module had a purpose and a set of entry points and its global information. And we had a programming technique for how to do that using Fortran. How to do information hiding in Fortran, how to do define entry points into modules in Fortran, how to do dynamic data structures in Fortran. People said you couldn't do dynamic data structures in Fortran, but we did linked lists and heaps and trees and the whole bit. So that was actually the most valuable thing. And I think that principle of modular programming is still something that is not well understood by many developers and engineers.